In this video, I'm going to be doing 3 problems relating to a data set taken from a sample from a population. So let me go over some terms real quick. I don't think they'll directly test this, but it's good to go over it. So a population, I'm going to just use people as the example. You can extrapolate it to other things. A population is everyone in the group of interest. So for example, let's say that you are having an election in your country. So the population would be everyone that's in the country that's eligible to vote. All right. Usually when we do statistical studies, it's very hard to get everyone in the population involved, meaning you go up to every single person and you ask them the question. So rather, to save time, we take a sample or a subset of that population. That's our sample. And it's important to have random selection or a simple random sample. So within your population, you randomly choose maybe like 200 people, or it depends on really what your study is and how significant the sample size needs to be to conclude your study. So maybe you just need 100 people and your population is 1,000. Okay, so in my case of the election, you might need a bigger sample to kind of represent your whole population better. And why do you want random selection? You don't want to have any bias in your sample. So if you don't randomly select people, let's just keep it simple. The election has 2 candidates. If you purposefully select everyone that is like in one political party, then they'll most likely vote for the candidate in that political party. So that likely won't be a good representation of the entire population. Okay, hopefully that kind of made sense. So you want to have random selection in order to try to eliminate any bias in your sample. Okay, so with that said, let's do this problem. Again, they won't really test you on the definitions directly, probably, but they might mention it here and there. So it's good to know those. Okay, so this says, a polling organization takes a random sample of 500 voters who voted for the mayoral election of a large western city. The organization gathered data right after the election, as shown in the table above. So the keyword here was random sample. Okay. According to the data above, what percent of people from ages 31 to 55 voted from candidate B? So go ahead and try to solve this one. This is a typical problem where they give you a table and you have to take pieces of information out of it. Okay, the answer should be B. How do we get B? It asks what percent of people from age 31 to 55 voted for candidate B. So the total number of people between 31 to 55, that is this row, so 210. How many of those 210 voted for candidate B? That would be 90. Okay? And if you put 90 divided by 210 in your calculator, that is 42.857%, something like that. So you round up to 43. All right. Total population of individuals in the city who voted for the election was about 450,000. Was the best estimate of the total number of votes for candidate B. So go ahead and try this one. All right. So this is exactly the case where you probably don't want to ask every one of the 450,000 people. It's going to take a lot of time. Your election is going to take, I don't know, months, maybe even a year, or maybe even more than 1 year. It really depends on if people are responding to you and how long, it takes for you to get to everyone. All right. So that's why they only chose a sample of 500. Is that large enough sample? Might not be, but we're not interested in that right now. We're going to directly try to extrapolate from the sample of 500 random people. We're going to extrapolate this result to the general population. Okay, so this is saying there's 450,000 in the entire population. So what is it asking? is asking for the total number of votes for candidate B. So candidate B, what percent of the 500 voted for candidate B? That's 212 divided by 500. And how much percentage is that? That is about 42.4, that is 42.4%. So let's assume this 500 people directly represents the whole population. So what is 42.4% of 450,000? So 450,000 times 0.424. I'm putting that in my calculator. That is 190,800. So rounding, best estimate is C. Okay, last one. According to the data above, how many times more likely is it for ages 18 to 30 years old to vote for candidate A than it is for 55 years or older to vote for candidate A? So go ahead and try this one. The answer should be A. So what percentage of people 18 to 30 voted for A? So 18 to 30, what percentage of them voted for A? That is 84 over 460. I'm sorry, 160. Okay, actually let's keep that as a fraction. All right, now how many of the 55 and up voted for A? So 55 plus, I'll say. All right, how many of those voted for A? That's 31 out of 130. It's asking how many times more likely is it for the 18 to 30s to vote for A than the 55 plus? So why don't we just take the ratio? Because, for example, if this is twice as likely, the percentage would be higher by 2 times. So let's just divide these two fractions. 84 of 160 divided by 31 of 130. Okay? That should give you about 2.2016, something like that. So about 2.2 times more likely. Okay? And that's it. So really, this is just testing if you can take out the pieces of information from this problem. All right? Should be quite easy, hopefully. But hopefully, if you didn't quite get something, my explanation was able to help you. As always, please like and subscribe if you found this video to be helpful. And in the next video, I believe we're going to be doing more things on probability instead. So if you're interested in that, please look out for that.